2.4, we'll be talking about this thing called average rate of change, and if we're going to talk about it, we should probably know what the heck it is. So let's start off with the definition. Wow, I can't spell today. Definition. The average rate of change. Now, in mathematics, in pre-calculus and calculus and beyond, you talk about average rate of change a lot. I'll be saying that word a lot, and I'm going to be very lazy. I don't want to write it a lot. So I'm going to abbreviate it as AROC. So AROC is average rate of change. So the average rate of change of a function, just a generic function, y equals f of x, between two x values, say x equals some number a and x equals some number b, so average rate of change is always between two numbers, is this formula. AROC equals the change in y over the change in x. And in math, the little delta symbol simply means change, so I guess I'll just write that. So that triangle pronounced delta means change. Which, if you wanted a formula, is f of b minus f of a over b minus a. Where in math have you guys seen that before? Gee, it's the change in y over change in x. Slope, that's it. That's the big mystery. Average rate of change is nothing more than slope. Right. So if you want to be all high-level pre-calculus-y, the idea is that the average rate of change, the AROC, is the slope of the secant line between 2 points. For you visual people, let's just draw a quick diagram. So if you just have a generic function, it's not going to be a real function. I'm just going to draw a little swirly here. So there you go. There's my function. Right. If I were to look at any 2 points, say this point here at x equals a, which of course has a y value of f of a, and say I want to look at this point here at x equals b, and he has a y value of f of b, what the AROC, or average rate of change, is taking a look at this vertical distance here. So this distance right here is the change in y, and this distance here is the change in x. Okay. Well, that just so happens to be the slope of the line that connects those two. So if you forgot geometry, learning about secant lines, tangent lines, and whatnot, a secant line is just a line that cuts through a graph. It doesn't actually, just touch it. It cuts through it. Right. So if you were to calculate the slope of this, I don't know, bluish, indigo, pinkish line, it would be the blue divided by the yellow. That's it. That's in terms of concepts. There we go. Let's just do an example really quickly. So let's suppose I asked you to, so for the function, say y equals x minus 3 quantity squared. Fine, and I'm going to ask you to, well, the practice is going to ask you two things. A, the net change between x equals 1 and x equals 3, and B, the AROC, average rate of change, between x equals 1 and x equals 3. Right. Now, if you forgot what net change was, and understandably it was a long time ago, like 2 days ago, here's to refresh your memories. The net change of a function f of x equals y between x equals a and x equals b is f of b minus f of a. Right. So that's the formula to find net change of a function between 2 points. It's the y value at the later x minus the y value of the former x. That's a suspicious looking formula. F of b minus f of a. Let's mosey on over. I'll scroll it back down. Let's mosey on over to the formula for AROC. Gee, there's f of b minus f of a. So that's all net change is. Net change is the numerator of your slope formula. So let's go ahead and do this problem. So in order to answer this question, I need the y values. They give me 2 x values, 1 and 3. We need the y values. So f of 1 equals, this notation simply means plug in a 1 for the x. So that is 1 minus 3 squared, which is negative 2 squared, which is a positive 4. And f of 3 is 3 minus 3 squared, which of course is 0. So we can answer the question. Letter A. The net change is equal to the function output at the bigger x value, 3, minus the function output at the smaller x value of 1, which is just 0 minus 4 is negative 4. Not too bad, I hope not. The only difference between question A and question B, net change versus the average rate of change, is the average rate of change, you simply divide by the differences in x's. So to do letter B, AROC, you take the net change, f of 3 minus f of 1, and then all you got to do is divide out the differences in the x. That's it. We've already figured out the top is negative 4, 3 minus 1 is 2, so the average rate of change is negative 2. Right. Those are the answers. Now we have to remember what AROC, or average rate of change, is. It's nothing more than slope. And we've learned since middle school, pre-algebra, that slope is rise over run. So this has some meaning. This says my slope is negative 2. On average, the original function loses 2 y values for every single x value. Now, AROC, or average rate of change, does change ideas if you're doing a word problem. But it's the same concept, if we're not dealing with x and y's, but rather, money and time, this could be, I'm losing $2 per minute. Or maybe we're talking about speed. I'm losing 2 miles per hour. If you're talking about, the cost per making an item, it's $2 cheaper for every item I make. So when the problem asks you to interpret what the average rate of change is, you just have to tie back into the story. What is it that we're talking about? Are we talking about money and time? Are we talking about distance and speed? So on and so forth. Any questions with this example? That's it. That's what 2-4 is all about. I'm going to give you a whole bunch of functions and stories, and I'm going to ask you to find the average rate of change. Nothing more than slope.